Good morning, friends. Today we're going to be going out to Westech Performance Group with our 1968 Nova to do some tuning on the chassis dyno. We're going to see if we can pick up a few extra horsepower and fix some of our drivability issues that we've got. Well, here we are at Westech Performance in Mira Loma, California. Let's go in and take a look. Oh, they're getting ready to strap the Nova down to the dyno here. We're going to put an oxygen sensor in first. Before we get any dyno tuning done, we got to weld an oxygen sensor bung onto the exhaust system so we can have really good feedback on our data from our fuel mixture. Here we are with Ernie Mina at Westech. He's going to be doing the tuning on our Nova. What's going to be our first move today, Ernie, and what did we see in that first test?
Right now we're going to go ahead and check the timing to make sure it's in specifications that I like. Also, we found out that it was running a little bit rich at idle, kind of on the edge of being lean at light throttle and absolutely lean at wide open. So we'll go ahead and do the jetting to get the air fuel where we want it to make the best power.
Well, we're almost finished with our first round of mods. Ernie Mina is putting our car back together. Ernie, tell us what we did here and maybe point out a couple of things on the carburetor.
Well, the first thing we did is we wanted to make sure what jet sizing was in the carburetor already. We found out that the primary jet size here was correct for what we were looking for. Secondary was kind of lean, so what we did is we added a power valve because the jet size was already at a 92 and I didn't want to step it up any bigger than that. So with the power valve added, we actually increased about 6 jet sizes. The other thing we did is we looked at the high-speed air bleeds to make sure they weren't plugged or too big, causing the jet to have issues, and those seem fine. They're at 24s all the way around. The other thing, we did have a stumble upon acceleration, so what we did is we changed the size, actually the length, of the accelerator pump rod, so we have a longer stroke, and we also changed the squirter to give us a little bit more fuel when we step on the gas for the burnouts.
Well, we're looking at the before and after dyno results. You can tell the first run was sort of aborted right here because the air-fuel ratio was so lean. And the second run, overlaid on top of that, is in the red, and you can see we pulled it all the way up to about 5,700 RPM. Tell us what's going on there, Ernie.
We're looking at basically, we got it to run a little bit richer, and I'd actually like to get the air fuel a lot flattered and see if we can get it around 12.8, 12.9 all the way through the run so we can go ahead and extend the RPM range out a little bit. Like I said, we did abort this run due to the air fuel ratio being on the lean side. I didn't want to hurt the motor, so we'll continue to go ahead and jet it up and do some timing sweeps for the next couple runs.
Ernie's going to make one small timing change here. Probably pull out a degree or two of timing and see if we pick up any power. Well, Ernie took out 2 degrees of total timing from 36 to 34 degrees, and you can see that we picked up about 6 horsepower on the top end, and we fattened up the torque peak down low pretty darn good. And we're going to put in a couple jets on the secondary. Going to go from 92 to 94, try to flatten out their fuel ratio up high. How we're making every one of our runs with the air cleaner on for consistency's sake. Adding 2 jet sizes in the secondary did give us a little bump right here in our power, right around 5200, and we have another 2-3 horsepower top end right here. Plus our air fuel ratio is a little bit more flat as we go through that transition area. One of the ways that Ernie can adjust the drivability of the car is by adjusting the load setting on the dyno. And that simulates going up and down hills and getting on and off the throttle. And you only get that with a super flow dyno. Well, we love our Performance Distributors HEI distributor. Now, there's nothing wrong with it. It is a race unit, however, and for the street, we actually need to have a little shorter spread between the initial timing and the total timing. So we're trying to see if we can shorten up that with the centrifugal weights. The idea here is that we want to limit the travel of the centrifugal weights as the RPM increases. And we got a good tip from Steve Davis at DOI, the maker of the distributor, and he said that we can just add a little screw right there, and that will limit the travel of that centrifugal weight. So we're going to try that and see if we can tighten up the timing. Okay, tell us what we've got now for the timing and what the mod was that we did on the distributor.
Okay, now we have actually 25 degrees of initial timing, and it sweeps to a total of 34 instead of from 15 to 34. So what we did, the guys at Davis Unified actually told us a little trick to use some 10-30-second bolts and nuts to limit the travel inside the distributor. So we were able to go ahead and get the timing sweep a lot closer.
Right on. And that will give us a lot more throttle response.
Yeah, the car with this size camshaft in it will give us a lot quicker acceleration from a low engine speed.
Okay, we've got run number 5 and run number 6 up together, and the only difference is we added 3 degrees of timing. Both of these runs are with the restricted movement on the HEI's distributor weights, so we think that maybe we were getting a lot more advance at high RPM than we thought before. So we got that back and then some. So this is pretty much where we're going to be. This is maxed out, right, Ernie?
Yeah, that's about all she's got.
That's really good considering that's coming through a power-hungry turbo 400, 385 at the wheels from Project Nova.